Hello students, so we were doing exercise 13.1. Okay, next question. So here you have to find limit as x tends to 0 fx and limit as x tends to 1 fx. Okay, so here two things are given. X less than or equal to 0, we have to use this function. For x greater than 0, we have to use this function. That is for a left hand limit, that is left side of 0, we have to make use of this function. Okay, for a right hand limit, you have to make use of this function. So left hand limit as x tends to 0 minus, you have to take this. So putting x equal to 0, you will get 3. Okay. What about right hand limit as x tends to 0 plus, so here 0, so it will be 3. Okay, right hand limit and left hand limit. So both are equal. So we can say that limit as x tends to 0, the value is 3. Okay. Now f of 0, that is 3. Okay. Next is we have to check for 1. 1 minus. Now here this is for x greater than 0, correct? 1. Oh, sorry, this is for minus 1, this is for 1. So left hand side of 1 is greater than 0, so we have to use this function, and for the right hand side also same function. Okay, so we'll get the same value actually, 6. And for limit x tends to 1 plus, it is again 6. Okay, so left hand limit is equal to right hand limit is equal to f of x as x tends to 1. Next question. So we have to find limit as x goes to 1. So for left hand, we have to take this function. For right hand, we have to take this function. X tends to 1 minus 1 minus 1. You have to put 1, not minus 1. Okay. So it will be 0. Minus 2. Okay. So here, your right hand limit is not equal to left hand limit. Okay. So limit is x tends to 1, fx does not exist. Expression, you have to find limit as x tends to 0, f of x. Function given is mod of x upon x. Okay, here there is no condition like less than 0 or greater than 0. For not equal to 0, we have to use this, and for equal to 0, we have to use this. Okay, so limit as x tends to 0 minus, so we have to use this function. So this is for the left hand side, so we have to take minus. All negative values we are considering. So mod of x will be minus x upon x. The answer is minus 1. For positive, we have to take x 1. Okay. So right hand limit is not equal to left hand limit. So at limit x tends to 0, fx does not exist. Okay. Same way you have to solve this. So for left-hand limit, x upon mod of x becomes negative. Answer is -1. For right-hand limit, it is positive. Okay. So again, left-hand limit is not equal to right-hand limit. So limit as x tends to 0, fx does not exist. Next question. Here also mod of x is given, but x is tending to 5. Okay, this is limit. So left-hand limit x tends to 5 minus. Okay, so here you have to take value. Same value will be 5 minus 5. Correct? 0. Limit as x tends to 5 plus x minus 5. Again the positive value. Here the condition is our x is greater than 0. Okay, if it was tending to 0, okay, the left hand side of 0 would have been negative, right? And right hand side would have been positive. That's why we took over there a negative value. And for this we took a positive value. But here 5 is there. So here also positive values are there and here also negative positive values are there. Very close values. Correct? That's why we are taking both positive values. So this is LHL is equal to RHL. So limit exists. Exists. 28. Fx is a plus bx 4 and b minus ax less than 1 equal to 1 greater than 1. Okay. Limit as x tends to 1, fx is given f of 1. What are the possible values of a and b? So first you have to find LHL. So for 1 minus you have to take this value a plus bx. So this is a plus b. Correct? RHL limit at x tends to 1 plus. You have to take this b minus ax. So this is b minus a. And it is given that a limit as x tends to 1 f of x is f of 1. Okay. That is f of 1 is 4. If these two are equal, then they are equal to f of 1, that is 4. Okay. So we are getting a plus b as 4 and b minus a as 4. So I'll write minus a plus b as 4. Okay. We have to solve this. B is 8 upon 2. 4. B is 4. What about a? A is 0. Okay. Next question, let a1, a2 till an be a fixed real numbers. Define a function f of x as x minus a1, x minus a2 till x minus an. What is limit x tends to a1 f of x for some a not equal to a1, a2, an? Compute limit x tends to a fx. So first we'll find limit as x tends to a1. F of x. So this whole thing you have to put here. Okay, so this becomes for each one. So now it is obvious that when you substitute here a1, this term is 0. So 0 into this whole terms becomes 0. So our limit as x tends to a1 is 0. Okay. Now we have to compute limit as x tends to a f of x. So a. Okay. So wherever there is x, you have to put a. So a minus a1, a minus a2 till a minus a. Okay. Next question. Fx mod x plus 1. So we have to what value of s of a does limit as x tends to a fx exists. Okay. So first we'll find out LHS 0 minus. So here you have to take less than 0, so negative values. So this becomes minus 1. It is 0. Sorry, this will be minus x. Now you have to put here 0. So this is 1. Okay. Same way for RHL 0 plus minus. So this is positive. Put here 0, so it will be 1. So we have, sorry, this is minus 1. So left hand limit is not equal to right hand limit. So our f of x does not exist. But the question is we have to find the value for which this f of x exists. Okay. So we have to put x tending to a. So wherever there is for LHL, it will be a minus, and for RHL it will be a plus. So this is for a less than 0, this is for a greater than 0. Okay. So for a less than 0, this is minus x plus 1. So minus a plus 1. For a greater than 0, x plus 1, a plus 1. Okay. Some mistake I've done again. Minus 1. A minus 1. So we want limit as x tending to a to exist. So this is equal to LHL is equal to RHL. Okay. So if you put minus a plus 1, so it will be 1 minus a. This is a minus 1. This to be equal, should be equal. Okay. Then only f of x exists. Next question, it is given that limit as x tends to 1, f of x minus 2 upon x square minus 1 is I. It is already given. You have to evaluate limit as x tending to 1 fx. Okay. So x square minus 1. You can write this limit as x tends to 1 fx minus limit as x tends to 1 2 upon limit as x tends to 1, x square minus 1 equal to pi. You can take this thing that side, so it will be into. Okay, and this is positive. This goes here, so it will be plus 1. This is a constant term, so you can take it inside also. And it will be same thing, 2. So I'll write it as 2. This we have to evaluate as limit x tends to 1, 1 minus 1, 0. So this thing becomes 0. You have to take this to this side. Okay. Next question, fx mx square plus n, nx plus n and nx cube plus n. For what integers m and n does limit x tends to 0 fx and limit x tends to 1 exist? Okay, so first we'll find out limit as x tends to 0. So LHL is this function. Go minus, so we take this function. So the answer is n. What about RHL? 0 plus this one. Okay. Let's find out LHL for 1. LHL for 1 is this, n plus n. Plus n. This is n plus n. Okay. So limit as x tends to 0, fx exists if this LHL becomes equal to RHL. So if m becomes equal to n. Okay. And this is already equal for 1 for 1. So limit as x tends to 1, fx exists. Okay.